different set of arrays. So let's run it now. You can see it is giving answer 4. So I will reiterate what and all things we have done here. I'll actually take it with the help of this example only. So what and all we are doing here, we are going to have different set of arrays, and from those arrays what we will have to do, just have to check which, but like we just have to divide it according to the number of sub arrays given to us. After dividing it, what we have to do, from those sub arrays we just have to find out the maximum sum, but out of all those combinations we have to find out the minimum sum. So that is how we have to do in this particular case. Correct? Now let us look into the third question. So it is saying you just have to create a program to check if the number is going to be an Armstrong number or not. And a number is considered as Armstrong if the sum of the cube of its digit is equal to the number or not. So what does it mean? It means so what it says if you are having one Armstrong number, what it is going to be there. Let us say you have something like 153. If you are going to do sum of cube of all its digits, so what and all digits do we have here? 1. Another digit is 5. Another digit is 3. So what we are doing, we took first digit, we did the cube. We took second digit, did the cube. Third digit, did the cube. Now just add all the sums. So it is going to return you 125, it is going to return you 27. If you are going to do this addition, what you will get? 153. So such a number we call as Armstrong number. So for this one, what we will be doing, our first approach has to be just divide this number by 10. So you know what and all we are going to do. So let us say you have your 153. So what you will do initially, this is going to be your number. You have to find out its remainder. So what is that? You are going to get 3. In your sum, what you will do, whatever remainder you are getting, you are going to do cube of that. So that is how you are going to get your sum. And then you have to update your number. How you will be updating it? By dividing it by 10. So if you are going to divide it by 10, what you will get? You are going to get 15. Now again you find out its remainder with 10. So if you are going to find out its remainder, what you will get? 5. So whatever value of sum you have, just you add cube of that number, that is 5 cube. Alright. Then again you divide this number by 10. So what you will be getting? You are going to get 1. What is the remainder which you will be getting in such a case? The remainder has to be 1. Correct? So that is something which you are going to do. So if you are getting your number equal to 1, or like even if you are going to do it, like what you can say, even if you are going to divide it again, what is the question which we are going to get? That is going to be 0. So unless you are getting that is 0, you will keep on doing it. And then what you will do, this number you are going to store it into some variable. Then from this number you are just going to do this comparison, that if your number is equal to this sum, in such a case you can say it is Armstrong number, otherwise not an Armstrong number. So that is what you can do in order to check for one Armstrong number. Okay, so what I will do, I'll just quickly take you to its code. Alright, so let us say we have number as 153. And why I am particularly taking 153, we have various other numbers as well. But this is something which I knew. So I have taken this number. You can take any other number and you can try. It is going to work. Okay, after that what I have to do, I'm just going to take another variable, that is going to be sum of cubes, or result I'll take. Anything you can take, okay? So let us say I'm taking it as 0. After that, what I'm going to do, I'm going to take variable temp. Why I'm taking this variable temp? If you remember the pattern problem, there also I was taking one temporary variable. And what this is going to do, later on we have to do the comparison. If I'm not going to store Like if I'm going to perform all the operation on this temp, in such a case later on this number is still going to have this value, and we can just compare and check if we are getting that result value equal to this sum or not. Okay, so what I'm going to do, I'm just going to have a loop while I'm going to check if your number is greater than 0, or I'll check it against temp. Okay, so what I will do, as long as this is going to be greater than 0, what you will have to do, first of all, you have to find out its remainder. How you can do, let me declare one variable here, remainder. How I'm going to find out the remainder, whatever value of temp you have, to that one you do mod 10. So this is going to return you the remainder, right? To this result, what you will do, whatever value previously you have, to that you just going to add cube of your remainder. After that, what we will have to do, we have to update our temp as well. So what we will do, we are just going to take your temp and then we will say temp like just divided by 10. But will it work? Answer is no. Why? Because if you are straight away going to do the division, it is going to return you the exact divided value that involves decimal. Do we want decimals? Answer is no. If we do not want decimals, we are going to do the percent. Why? Because this one is actually taking the quotient which you will get after dividing this value by 10. We are not interested into having the exact decimal value. So that is why we are going to do it in this case. Then later on, what you just have to do, just check if your number is equal to the or not. If it is there, just print Armstrong number. Otherwise, you can print not an Armstrong number.
Yes, beta, yes. I'm knowing.
Alright, and if you really want to see how the numbers are actually getting updated, what you can do, here you can put a console log having all these values. The remainder, then you can put some space. I'm not actually designing it by using some backticks or anything, because my concern is just to show if that is coming equal or not. But this one I'm doing so as to show you the step by step. So initially what I did, like even in this, what I was saying, it is going to take the remainder 3 and that is what is going to get added first, right? So here if you can see, firstly we got this as the remainder, this as the sum, cube of that, right? And then this is going to have the quotient 15. So that is what we were getting here, right? So in the next one, what we are getting 5 as the quotient, 5 as the remainder. This has added 27 plus 125. So that is how you got 153. And then this was the quotient. In the third one, you got 1 and then 153 and then 0. And later on, this is actually becoming equal to the given number. So it is saying Armstrong number. If we would have given it some value like 151, in such a case, you can see it is saying not an Armstrong number, but with 153, it is going to say this is an Armstrong number. All right, then let's see if this is what was there in the slide or not. They have not given any example, but that is how it is going to work.